In this question, we have a sample that contains 1.4 moles of diatomic fluorine gas at STP. That means standard temperature and pressure. Our goal is to find the volume of this sample of gas under those conditions. Okay, so let's head to our equation sheet. So if we have a look down here, we've got standard temperature and pressure. STP is defined as 273 Kelvin and 1 atm. And we're told that at STP, 1 mole of gas equals 22.4 litres. So let's write that all down. So STP means 273 Kelvin, and it means 1 atm. And at STP, 1 mole of gas takes up 22.4 litres of volume. Now, before we actually do the question, I just want to show you why and how we know that 1 mole of gas is equal to 22.4 litres of volume at STP. So to do that, we're going to use our ideal gas law. Going back to our reference sheet, we have our ideal gas law at the top here, which tells us the relationship between the pressure, volume, number of moles, R, the molar gas constant, and the temperature. So let's go and write that equation down. We've got PV equals nRT. So if we want to find the volume of 1 mole of gas at STP, we're going to be putting in all of those values for standard temperature and pressure into this equation to see what the volume is. First, let's rearrange to find V on its own. So I'm going to divide by P on both sides to get rid of the P. So I've got V is nRT divided by P. So let's put in all our values for 1 mole of gas at standard temperature and pressure. So N is the number of moles. We just want to find out for 1 mole of gas. R is the molar gas constant. If we look on our reference sheet, the molar gas constant here, we want to use litres and atm for volume and pressure. So we're going to use this version of the molar gas constant, 0.0821. 0.0821 for R, multiplied by the temperature. At standard temperature and pressure, the temperature is 273 Kelvin. And then we're going to divide by the pressure. At standard temperature and pressure, STP, the pressure is 1 atm. So if we put those numbers into our calculator, we get out 22.4 litres. So using the ideal gas law, we find that if we're at standard temperature and pressure, 273 Kelvin and 1 atm, 1 mole of gas has a volume of 22.4 litres. So that's the work to do to get to this shortcut, which we're going to be using from now on. But you have to remember this only works at STP, standard temperature and pressure. We can't use it for a question if the temperature or pressure are different. In that case, we'll have to go back to using this equation for the ideal gas law. Okay, so back to the question. We're now just going to use 1 mole equal to 22.4 litres as our conversion factor to convert our moles into a volume. So I know that if I'm converting from moles into volume, I'm going to have to divide by moles on the bottom so that they'll cancel out. And I'm going to have litres on the top, which is volume, so that that'll be my unit in the end. And then I know that what's on top and bottom of my dimensional analysis table has to equal each other. So if I have 1 mole on the bottom, that's equal to 22.4 litres. So that's going to be the things that go in my table here. And now I'm ready to go ahead and multiply anything on the top and divide by anything on the bottom. Now the moles are going to cancel out. So I'm left with 1.4 multiplied by 22.4 litres divided by 1. And if I put that in my calculator, I get 31.4 litres as my answer. So let's check that now. So the actual conversion works just like any others that we've done. It's very straightforward, but this is the conversion factor we're using. But you could only use it at STP. Let's do one more question together. So in this question, we have a sample of diatomic nitrogen and it has a volume of 76.6 litres at STP. We're trying to find how many moles are in the sample. So since it says STP, we know we can use this conversion factor. 1 mole equals 22.4 litres. So in our conversion table, we're going to need to put litres on the bottom so that will cancel out, and moles on the top since that's what we're trying to find. And then we're going to have the top and the bottom of our equation equal each other. So we've got 1 moles is equal to 22.4 litres. So that's the top and bottom of our fraction. Now we're ready to go ahead and multiply everything on the top and divide by everything on the bottom. And the litres are going to cancel. So we're left with 76.6 multiplied by 1 mole divided by 22.4. So we put that into our calculator. That gets us an answer of 3.42 moles. So let's check that in our answer box here. Awesome. So again, this works like any other dimensional analysis problem where we're converting. Just remember, whatever unit we start with, that's going to go on the bottom. The unit we're trying to find is going to go on the top. And that's how we're going to convert. And we're using 1 mole equals 22.4 litres only when we're at STP. If it's not at STP, we cannot use this conversion, and we have to use the ideal gas law to find the conversion factor.